Hi, today we're going to be revising the basics of algebra that you should already know. We're going to start off by looking at the language that we use in algebra, just to remind you about what all the different terminology means. So the first term is a variable. A variable is a letter or symbol that represents an unknown value and it can change value. An algebraic expression is a mathematical phrase that contains numbers, variables, and operations. There is no equal sign in an algebraic expression. If there's an equal sign, it means it is an equation. An algebraic expression represents a value that changes depending on the value of the variables in the expression. A constant is a number that does not change. It will always have the same value. A coefficient is the number that multiplies a variable. That's the number that you will see in front of the variable. And if there is no visible number in front of the variable, it means that the coefficient is 1. The coefficient tells us how many of a particular variable or set of variables there are. So if you have 5x, it means it's x plus x plus x plus x plus x. There are 5 x's being added together. A term is a single number, variable, or a combination of numbers and variables that are being multiplied together. Terms are separated by addition or subtraction signs, and the sign, the plus or the minus, is considered part of the term that follows it. A polynomial is an expression with one or more terms. A monomial is an expression with only one term. A binomial is an expression with 2 terms, and a trinomial is an expression with 3 terms. Each of those, a monomial, a binomial, and trinomial, are all different kinds of polynomials. Like terms are terms that have exactly the same variables and exponents. Their coefficients can be different though. Okay, so as long as the variables and the exponents are the same, they are like terms. Only like terms can be added or subtracted. And in order to combine like terms, we need to add or subtract the coefficients, that's the numbers in front, keeping the variables and the exponents unchanged. Okay, and we're going to practice that a little bit later. But first we're going to go on to finding the value of algebraic expressions using substitution. So if you are asked to find out the value of an algebraic expression and you're given the values of the different variables, you're going to use substitution to do that. Okay, so first what you're going to do is replace the variables with the given values. And don't forget that when you're replacing the variables with the values, you need to put them in brackets. And then once you have done the actual substitution, once you have replaced the variables with the values in brackets, you then need to go and simplify the expression using BEDMAS. Okay, so let's have a look at our first example for today. In this example, we have to determine the value of the following expression if a is -2 and b is -1. So in this expression, we've got a cubed plus 3a squared b minus 3ab squared plus b cubed in brackets. So let's have a look at how we would do that question. Okay, so here I've got my expression. So the first thing we're going to do is we're going to replace all of the variables with the values that we've been given for those variables, putting them in brackets. So a is -2, so I'm going to have -2 in brackets cubed, plus, then I've got 3, then a squared b. I'm going to replace the a with -2 in brackets, and that is squared, and then the b is also going to go in brackets, and that's -1. Minus, then I've got brackets over here, and inside those brackets I've got 3, and then a, which is -2, that goes in brackets, and then b squared, which is -1, goes in brackets as well. And then I've got plus b cubed, which is -1, so that's going to be -1 in brackets, cubed, and then I close the brackets that is all in. Okay, so once I've gone and done all the substitution, now what I need to go and do is need to go and simplify everything, remembering to do things in the order of BEDMAS. So according to BEDMAS, I need to do brackets, then exponents, then division and multiplication, and then addition and subtraction. But now remember, you can work with your terms separately. So let's first have a look and see where our terms are. So here's my first term. That is one term over there, up to that plus, which isn't inside brackets. Then I've got from the plus, including the plus, up to the minus over here that's not inside brackets. And then I've got over here from including the minus, up to the end. So I've got 3 terms in this expression over here that I need to go and simplify. So the first one over here, the only thing I have to do in this term is cube that -2. Okay, now when you cube a negative number, it's going to stay negative. Remember, when you've got a negative number being raised to an odd exponent, it stays negative. So it's going to be negative, and then 2 cubed is 8. Okay, then I've got plus. Then over here in my next term, I've got a few things that I need to do. I've got a 3, then I've got -2 squared, and then I've got that multiplied by -1. So I'm going to leave the 3 and the -1 as they are at the moment, because I have to do the exponent first. So 3 stays as it is. The -2 squared, remember when you are raising a negative number to an even power, then it is going to become positive. So it's going to be positive 4, and I'm going to keep that in brackets because I'm still going to have to multiply it. So it's 3 times 4 and then times the -1 over here. Then over here, I've got quite a lot that's happening in this last term over here. I've got a minus, and then I've got my brackets. Then inside my brackets, over here, I've got 3 times -2 times -1 squared. Once again, I have to do that exponent first. Okay, so remember, when you are working inside brackets, you apply bedmass inside the brackets as well. So I'm doing this term inside the brackets here, and in that term, I have to do the exponents first. So I've got 3, then -2, then the -1 squared becomes +1. Then over here, I've got plus, then -1 cubed. Now this is another term inside the brackets here. I'm going to do the cubing over here. -1 cubed is -1. Remember, when you have a negative being cubed, then it stays negative. Okay, so inside the brackets over here, I've got 3 times -2 times 1, and then plus -1. Okay, so now let's go and do our next line. So over here, the first term is done. I can't do anything else with that term. The second term, from the plus over here to the end of those brackets, is 3 times 4 times -1. I need to now go and multiply those together. So the -8 is staying as it is. But here I've got +3 times 4 times -1. Positive times negative is a negative. 3 times 4 times 1 is 12. Okay, so I've got -8 minus 12. Then over here, I need to still go and simplify what's inside the brackets before I can get rid of the brackets. Okay, so I've got negative. Then over here, 3 times -2 times 1 is -6. And then if I add a negative, it becomes negative. So it's -1. Okay, so now we're going to go and simplify the last part of this over here. So I've got -8 minus 12. I'm not going to do anything with those yet. But over here, I have minus -6 minus 1 is -7. Okay, so now I can go and get rid of those last brackets over there. So I have -8 minus 12. Negative and a negative makes a positive, so it's +7. So now -8 minus 12 is -20, plus 7 is going to be -13. So that's what you should get for that question. Okay, so now I'm going to give you a few that you're going to do for yourself. Here's the first one that you're going to do. We've got, if P is 4 and Q is -2, you need to calculate the value of the expression 5P minus 3Q plus Q squared. I'm going to give you 1 minute to work this one out. Okay, so let's go through that question and see what you should have got. So first of all, we take our expression, we need to go and substitute in the values that we have been given. So we've been told that P is -4 and Q is -2. So over here, I've got 5 multiplied by P, which is 4. So I'm going to put 4 in brackets over there, minus 3, and then my Q is -2, and that also goes in brackets, plus, and then I've got q again, and so it's negative 2 in brackets, and that is being squared. Okay, so now I need to go and simplify. So if I look at my terms over here, I've got one term over here that's 5 times 4. Then I've got another term that's negative 3 times negative 2. Then I've got another term that's plus, and then negative 2 squared. Okay, so the first term, the only thing I have to do is this multiplication. And to multiply the 5 and the 4, that gives me 20. The next term, I again only have multiplication, is negative 3 times negative 2 gives me positive 6. And then the last term over here, I've got plus, and then negative 2 squared. Now negative 2, when you square it, is going to become positive 4. Because it's positive, I don't need to write the brackets anymore, because I've just got a plus and a plus, which just makes a plus. So it's going to be plus 4. So now I can go and simplify that. So 20 plus 6 plus 4 is 30. So that's what we should have got for question A. Right, now let's go on to question B. In question B, you have to find the value of the expression 3x plus 5y over y minus x if x is equal to negative 4 and y is equal to 2. I'm going to give you 1 minute for this question as well. Okay, so let's go through that question and see what you should have got. So we're starting off over here with 3x plus 5y over y minus x. So we're going to go and substitute in the values that they gave us. So they told us that x is negative 4. So it's going to be 3 times negative 4 in brackets plus 5 times, they told us y is 2. So it's going to be 2 in brackets. And that all goes over our denominator, which is made of y minus x. So it's going to be at the bottom of a fraction y, which is 2. Now, this particular one, because there is nothing in front of the y, it's not being multiplied by anything, you actually can just write 2. You don't need to put that in brackets. If you aren't sure though, put it in brackets to be safe. So I've got 2 and then minus, and then the x is negative 4. Now here I have to put the brackets because I've got a minus, and then I've got a negative 4 over here. Okay, now we're going to go and simplify this. So first of all, at the top of my fraction, I have got my 3 times negative 4, that gives me negative 12, plus 5 times 2 is plus 10. Okay, so at the top I'm doing these terms separately, like that, and like that. Oh, this is actually there. Okay, and at the bottom I've got a term over here which I can't do anything with, and I'm going to go and simplify this as well. So over here at the bottom of my fraction, I've got 2, and then minus negative 4 becomes plus 4. So at the top of my fraction, I have negative 12 plus 10, and that gives me negative 2. Over, at the bottom of my fraction, I've got 2 plus 4, which gives me 6. So now I've got negative 2 over 6. Now if we simplify that, 2 goes in here once, 2 goes in there 3 times, which gives us 1 over 3, but it's negative. So I'm going to put my negative 1 over 3. If you put the negative in front of the 1, that's also fine. But if the minus is in front of the 1 or if it's in the front of the fraction, they both mean the same thing. So you could have the minus here or you could have the minus in front of the 1. Okay, so that's what you should have got for that question. Right, now we're going to go on to simplifying algebraic expressions. So now we're not going to be working out values of algebraic expressions. They're not going to be giving us values for the different variables and asking us to work out what it's equal to. Now we're going to be simplifying it, writing it in the simplest way possible. Okay, so remember, when you are simplifying algebraic expressions, you can only add or subtract like terms. Okay, so let's have a look at our first one. For this one, we need to simplify as far as possible. You've been given the expression 3a times 4ab minus 7a times 2b squared plus 5 times 3a minus 5a squared times 4b plus 9ab times 2b. Okay, so let's have a look at how we would do this question. Okay, so here I've got the expression written down. It's quite long, okay, but it's not very difficult to actually work this out. All we need to do is take each of the terms. So I look for my pluses and minuses to see where the terms are separated. So here's a minus. So this is my first term over here. The second term is from that minus up to before the plus over here. The third term is from the plus up to before the minus over there. The fourth term is from the minus up to before that plus over there. And the fifth term is from the plus up to the end. Okay, so in the first term, I've got 3a times 4ab. So I'm going to multiply my numbers together. 3 times 4 is 12. So when we're doing this, we're going to be multiplying the numbers together, and then you multiply the things that have the same base. So a times a is a squared, and then times b. Okay, so we write it in alphabetical order. The a's go first, then the b's go next. The numbers will always be in the front. Okay, so I multiply my numbers together, I multiply the same variables together. A times a is a squared, and then I've got my b over there. Okay, the next term, I've got negative 7a times 2b squared. So it's negative, because it's a negative times a positive. And then I multiply my numbers. 7 times 2 is 14. Then I've got a and b squared. Neither of those are the same base, so I'm just going to write them down in alphabetical order. So I've got a and b squared. Okay, then I've got a positive times a positive is plus. 5 times 3 is 15. And then I can't multiply the a by anything, so it just stays a. Then I've got over here negative 5a squared times 4b. So that's going to be negative 5 times 4 is 20. And then a squared times b, neither of those are the same base, so I'm just going to write them down in alphabetical order. So a squared and then b. And then I've got a positive times a positive is plus. 9 times 2 is 18. Now here I've got a, and there's no a's there, so it's going to be a over there, and then b times b is b squared. Okay, so that's what my second line should look like, where I've done all the multiplication within each of the terms. Now I'm going to go and look for my like terms. So I want to identify which terms have exactly the same variables and exponents. Now, all of these, except for that one, all of them have got a's and b's. But just having the same variables isn't enough. They have to have the same number, the same variables, and the same exponents on those variables. So over here, this is a squared b. This is ab squared. They're not the same as each other. They're not like terms. Over here, I've got a. It's got an a, but it doesn't have b, and it doesn't have b squared. Okay, so that's also not the same. Here's another a squared b. So these ones are the same as each other. I've got 12a squared b and negative 20a squared b. Those are like terms. So they are going to be combined. Then I also have over here negative 14ab squared. That is the same, or is a like term with this one over here, 18ab squared. They are like terms. And then this 15a over here doesn't have any partners. There's nothing that's a like term with that. So it's going to stay as it is on its own. Okay, so what I'm going to do now is you can write the next step where you combine the like terms, or you collect the like terms. You don't have to. You can go straight to the answer, but I'm going to write the next step so that you can see how we are grouping them. Okay, so we've got 12a squared b. And then I've got the minus 20a squared b. Now remember, the plus or the minus belongs to the term that follows it. So the minus is part of that term. It has to move with the term. So it's minus 20a squared b. Okay, then I've got my minus 14ab squared. And I've got a like term for that, which is this one over here. So that's plus 18ab squared. And then this plus 15a is just going to go on the end over here on its own because there's nothing that goes with it. Now we're going to go and simplify our like terms. We're going to combine them. So 12a squared b minus 20a squared b. So when we combine our like terms, the variable part of it is going to stay the same. We're going to only be adding or subtracting the coefficients, the number part that's in the front. So I've got 12 minus 20. Now we know that 12 minus 20 is negative 8. So it's going to be negative 8. And then the a squared b is going to stay the same. So it's negative 8a squared b. Okay, then the next set of like terms I've got is the ab squared and the ab squared here. So I've got negative 14ab squared plus 18ab squared. So I'm going to take the negative 14 and add the 18, and that gives me positive 4. And the ab squared is going to stay as it is. It doesn't change, okay? And then the 15a, there's nothing I can do with it because there are no like terms for it, so it's going to stay as it is, but I can't leave it out. I have to still write it down. So that's negative 8a squared b plus 4ab squared plus 15a. Okay, so that's what we should get for that question. Now let's go and have a look at another example. In this example, we've got some fractions to worry about, okay? So it's going to become a little bit more complicated. We've got 1.5x squared plus 5 over 6x times 2y minus 3y times 5 over 18x minus 4 over 7x times 21 over 8x. Okay, so here, everything that you've learned about fractions is now going to be brought into what we're doing in our algebraic expression over here, but it's still going to all work in the same way. So let's have a look at how we would do this question. Okay, so the first thing I'm going to do for this question is I'm going to identify where my terms are. Okay, so my first term is this over here. I've got 1.5x squared, and then I've got a plus. So that's the end of that first term. The second term is from the plus up to, but not including that minus over there. Okay, then the next term is from the minus up to just before that, the next minus, and then the last term is from the last minus over here to the end. So those are my 4 terms in this question. Right, so now let's have a look at what we need to do in each of these terms. So in the first term, I don't have any calculations to do in that term, but I want to convert that 1.5 to an improper fraction. I don't like having a mixed fraction because it's going to make things a little bit more difficult to work with later on. So I'm going to convert that to an improper fraction. So 1.5 is the same as 1 times 2, which is 2, plus the top one is 3 over 2. So that's 3 over 2x squared. So when I've got a fraction in my coefficient, or when my coefficient is a fraction, I still work with a fraction in the same way that I normally would. The fact that there's a variable after it doesn't make any difference to what I'm doing with this fraction over here. Okay, then I've got 5 over 6x times 2y. Okay, so now, just like when we were doing the last example, we're going to multiply our numbers together, and then we're going to multiply the variables. Okay, so over here, my numbers are 5 over 6 and 2. Okay, now if I multiply these together, remember the 2 is the same as 2 over 1. Okay, so I'm going to multiply and cancel out my things that I can cancel out here. So this is my top of the fraction here, this is the bottom of the fraction. 2 goes in there once, 2 goes in there 3 times. I can't cancel anything with the 5 over there or the 3 over there. So now I'm going to say I have 5 times 1 and 3 times 1. So that's 5 over 3. So that's plus 5 over 3, and then I only look at my variables. So while I'm doing that multiplication of the fractions, I'm just ignoring the variables completely. I'm not worrying about those. Now I'm going to go and do my variables. So I've got x and y. Now because neither of those have got the same base, I can just write them down in alphabetic order. So I've got 5 over 3, and then x and y. Okay, now we have the next term over here. We've got negative 3y times 5 over 18x. Okay, so same thing as the last one. I'm going to multiply my numbers, which are the fractions. So I've got 3 over 1, and I'm multiplying that by 5 over 18. So the 3 goes in there once, and 3 goes in there 6 times. Then I can't simplify anything else, so that gives me 5 over 6. Okay, so I've got minus, because it's a negative times a positive, is negative. So minus 5 over 6, and then once again, my x and my y, neither of them are the same base, so I'm just going to write them down in alphabetical order. So the x goes first, and then the y goes next. Okay, then over here, my last term, I've got a negative times a positive, again, that's negative. And now I'm going to go and simplify, multiplying my fractions together. So 4 over 7 times 21 over 8. 4 goes in there once, 4 goes in there twice. 7 goes in there once, 7 goes in there 3 times. That leaves me with 3 over 2. And then I've got x times x, which is x squared. So now I need to go and collect my like terms. Now, like I said previously, you can skip the step of actually writing them together. But when you've got fractions, it actually makes it easier if you do write them together, because you're going to be now having to worry about finding the same denominators and things like that. So it does help if you write them together. Okay, so I'm going to collect my like terms. first of all, I've got an x squared over here, and I've got an x squared over there. Then I've also got xy over here and xy over there. Okay, so I'm going to collect my like terms, writing them together. So I've got 3 over 2 x squared minus 3 over 2 x squared. So that's those ones. Then I've got plus 5 over 3 xy and minus 5 over 6 xy. Okay, so once I've got that, I can now go and simplify. Now this over here is actually very easy because I've got 3 over 2 x squared minus 3 over 2 x squared. 3 over 2 and 3 over 2 are the same as each other. When you subtract something from the same thing, you end up with 0. They cancel each other out. So these over here are going to cancel completely. So I don't have to worry about the x squareds at all. They are gone. Okay, so now I'm going to only be worrying about the xy's over here. So I've got 5 over 3 xy and minus 5 over 6 xy. Okay, so what I need to do now, remember when you are adding and subtracting fractions, you need to make sure that you have the same denominator. So over here, I've got a denominator of 3 and a denominator of 6. They are not the same, so I need to write down what my LCD is, my lowest common denominator, and change this to have that LCD. So the denominator is going to change from 3 to 6. So it's going to become 10 over 6 because I multiply that the bottom by 2 to get 6. So I need to multiply the top by 2 as well. So it's 10 over 6, and then the xy doesn't change. Okay, so remember we're only doing stuff to the coefficients here. Minus 5 over 6 xy. Now I'm going to go and simplify the 10 over 6 minus 5 over 6. So that is 10 minus 5, which is 5 over, and the denominator doesn't change. So it's 5 over 6 xy. So that's what you should get for that question. Okay, so now I'm going to give you a few that you're going to do for yourself. We're going to start off with this one over here. You've got 7m squared times 3n plus 3m times 4n squared minus 5mn times 2n minus 8m times 2n minus 5m times 3mn. Okay, so I'm going to give you 2 minutes to do this question. Okay, so let's go through that question and see what you should have got. So over here, the first thing we're going to do is identify where our terms are. So over here, I've got 7m squared times 3n. That is my first term. Then I've got plus 3m times 4n squared is my second term. Then minus 5mn times 2n is my third term. Minus 8m times 2n is my fourth term. And minus 5m times 3mn is my fifth term. Okay, so now let's go and simplify each of those. So in the first term, I'm going to multiply 7 by 3 gives me 21. and then m squared n. Then I've got a positive times a positive is plus, 3 times 4 is 12, and then m and n squared. Then a negative times a positive is minus, 5 times 2 is 10, then I've got m times n times n. So the m doesn't have any same basis, but the n and the n need to combine to give me n squared. Then I've got negative 8 times 2 is negative 16, and then times m and times n, so it's m n. And then negative 5 times 3 is negative 15. Then I've got m times m is m squared, and then I've got my n over there. So that you should have got for your second line, where you combined all of the, or you multiplied in each of the terms. Okay, now we're going to go and find our like terms. So over here, I've got 21m squared n. Let's see if there's anything that has the same variables and exponents as that. So this is not the same. Mn squared is not the same as m squared n. And here I've also got mn squared. Here I've got just mn, and here I've got m squared n. So this is the same as that. Okay, those are like terms. Then over here I've got 12m squared n and minus 10m squared n. Those are like terms, but this one is not. It's completely different because it doesn't have any squares at all. So it is going to stay on its own like that. Okay, so let's go and collect our like terms. Now remember, you didn't have to show this step, but I'm going to show it anyway. So I've got 21m squared n minus the 15m squared n. Then I've got plus 12mn squared and minus 10mn squared. And then I've got my minus 16mn. Okay, so let's go and simplify by combining our like terms. So over here, 21m squared n minus 15m squared n. Remember, the m squared n is going to stay as it is. I'm going to be subtracting my coefficients, that big number. So 21 minus 15, that gives me 6. So it's going to be 6m squared n. Then the 12mn squared minus 10mn squared, I've got 12 minus 10 is 2. So that's plus 2. And the mn squared doesn't change. And then I've got my minus 16mn, which is on its own and is not going to change. Okay, so that you should have got for that question. Right, now let's go on to the next question. In question B, you've got 0.5e times 0.4e minus 3f times 0.7e squared plus 2 times 0.4e squared plus 0.05e times 2ef. Okay, so in this question, now you've got coefficients that are decimal fractions. So you have to use what you know about working with decimal fractions to help you with this question. So I'm going to give you 2 minutes for this one as well. Okay, so let's go through that question and see what you should have got. Right, so over here, the first thing we're going to do, once again, is identify where our terms are. So I've got 0.5e times 0.4e, that's my first term. Then I've got negative 3f times 0.7e squared, that's my second term. Then I've got plus 2 times 0.4e squared is my third term. And plus 0.05e times 2ef is my fourth term. Okay, so in the first term, I'm multiplying together 0.5 and 0.4. Okay, so now remember, when you're multiplying decimal fractions, you multiply the number part of it, you ignore the zeros and the decimal points, and you just multiply the numbers, and then you see how many decimal places you should have. So 5 times 4 is 20. Now, in this over here, I've got 1 decimal place there and 1 decimal place there, so my answer should have 2 decimal places, the total number of decimal places. So it's 0.20. Okay, but now I don't need to write that second 0. So it's just going to be 0.2, and then the e times e is e squared. So that you should have got for the first one. 0.5 times 0.4 is 0.2, and then e times e is e squared. Okay, then I've got a negative times a positive is negative. 3 times 0.7, again 3 times 7 is 21, but over here I've got 1 decimal place. So I need to have 1 decimal place in my product as well. So it's going to be 2.1. And then e squared goes first because in alphabetical order e is first, and then I've got f. So it's 2.1 e squared f. And then I've got a positive times a negative, or positive times positive is plus, and 2 times 0.4, 2 times 4 is 8. There is only 1 decimal place here, so I need to have 1 decimal place, so it's going to be 0.8, and then it's just e squared. And then over here I've got, again, a positive times a positive is plus 0.05 times 2. 5 times 2 is 10, and I've got 2 decimal places here, none over there, so I need to have 2 decimal places. So it's 0.10 for the 10, but I don't need to write that 0, so 0.1, and then e times e is e squared, and then I've got f. Okay, so that's what you should have got for your second line of work, where you've done all the multiplication. Now we're going to go and collect our like terms. So I've got over here an e squared. Then over here I've got e squared f is not the same. Here I've got plus 0.8 e squared again. And then I've got 0.1 e squared f. These ones over here are like terms as well. Okay, so now let's go and put them together. Like I said, you don't have to show the step. It's up to you. So I've got 0.2 e squared plus 0.8 e squared. And then over here, negative 2.1 e squared f plus 0.1 e squared f. Okay, so now I'm going to go and simplify those. So for my e squared, I've got 0.2 plus 0.8. If I show it to you over here, I've got 2 plus 8, so 0.2, sorry, plus 0.8. 2 plus 8 is 10. Then I've got my comma over here, so that's 1 plus 0 is 1. So it's 1.0, okay? But now I don't need to write 1.0, I just need to write 1. But because it's a coefficient, I don't even have to write the 1 because the e squared is going to be there. And so I don't need to write the 1 in front of it. Remember, 1 e squared is the same as e squared. So that is just e squared. Okay, then I've got over here minus 2.1 plus 0.1. So if I go and simplify that, 2.1, remember when you are subtracting, you take the one that has the bigger absolute value and you subtract the one that has the smaller absolute value, and then the answer gets the sign of the one that was bigger to start with. Okay, so I'm saying 2.1 minus 0.1. Can you see that? There we go. Okay, 2.1 minus 0.1. So 1 minus 1 is 0, and 2 minus 0 is 2. Okay, so that's 2.0, right? So this is going to be, because the bigger one, or the one that had the bigger absolute value, was negative. Remember, the absolute value is the distance from 0 to the number. So the absolute value for negative 2.1 is 2.1. Okay, so it's going to be negative because the one that has the bigger absolute value is negative. So it's negative 2. Now, I don't need to write 2.0. Again, that 0.0 I don't need to worry about. So it's just 2, and then e squared f. So that's what we should have got for question B. E squared minus 2 e squared f. Right, now let's go on to the last one for today, which is question C. In question C, you've got some common fractions as your coefficients. you've got 5 over 8a squared times 18 over 15 minus 4 over 5a divided by 1 over 2 minus 1 over 2a times a plus 2 and 3 over 5a. Okay, so I'm going to give you 4 minutes for this question. Okay, so let's go through that question and see what you should have got. So once again, I'm going to first look and see where my terms are. So I've got over here my first term, 5 over 8a squared times 18 over 15. My second term is this negative 4 over 5a divided by a half. Then I've got my third term, which is negative half a times a. And my last term is plus 2 and 3/5 a. Okay, right, now we're going to go and simplify each of these terms. In the first term, let's see what I can do over here. When I'm multiplying these fractions together, I can cancel out the 5 and the 15. 5 goes in there once, 5 goes in there 3 times. Then I've got 3 and 18. 3 goes in there once and 3 goes in there 6 times. And then the 8 and the 6 I can simplify. 2 goes in there 3 times and 2 goes in there 4 times. So you're left with 3 over 4. Okay, so over here I've got 3 over 4 a squared. Right, then negative 4 over 5a divided by a half. So in this term over here, I need to tip in times. And I just want to bring your attention to the fact that this half over here does not have an a or anything after it. If it did, I would have to treat this a little bit differently. We're going to learn about algebraic fractions later on, and then you will see about other ways of dealing with these things. But over here, because it doesn't have an a or anything after it, I can just tip in times normally. Okay, so I've got negative 4 over 5a times 2 over 1. So I'm going to tip in times that, and then I'll go and simplify that in the next step. Right, then over here I've got minus in the next term. So negative times a positive is negative. Then a half times 1 stays a half. And a times a is a squared. And then the last term, the only thing I have to do here is change that to an improper fraction. So it's going to be plus 2 times 5 is 10, plus 3 is 13 over 5. And that is a over there. Okay. So now I still need to go and simplify this term over here. I'm not done with this term yet. The other terms I'm done with, but that term I'm not done with. So I need to go and simplify that. So I've got 3 over 4a squared. Then over here I have negative times a positive is negative. 4 over 5 times 2 over 1, I can't cancel anything out. So I'm just going to multiply the numerator. So it's 4 times 2 is 8. Over 5 times 1 is 5. And then a times nothing, it's just a over there. Okay. Then this and that are going to stay as they are because they are already simplified. So I've got half a squared plus 13 over 5a. Okay. Now we're going to go and find our like terms. So over here I've got 3 over 4a squared. Then over here I've got minus a half a squared. And then I've got negative 8 over 5a and positive 13 over 5a. Okay, so I'm going to collect my like terms. Now, like I said, when you're working with fractions, it does make it easier if you write them together, because now we're going to be finding lowest common denominators, and they're going to be specific to what I'm adding up. Okay, so over here, I've got 3 over 4a squared, minus a half a squared, and then I've got negative 8 over 5a, and plus 13 over 5a. Okay, so now when I'm finding the LCD, I'm going to find the LCD for the things that I'm adding together. I'm not going to find an LCD for everything because I'm not going to be adding those with those. I'm going to be working with these together. So I need to find an LCD for them, and I need to find an LCD for these as well, but they're separate from each other because I can't add the a squareds and the a anyway. Okay, so over here, for the a squareds, I've got 3 over 4 and I've got 1 over 2. The LCD here is going to be 4. So it's going to be 3 over 4 a squared minus the 1 over 2 is going to be 2 over 4, also a squared. Okay, so now I've got the same denominator, which means I'll be able to simplify that in the next step. Then over here, these have already got the same denominator, so I don't need to do anything to them. I can keep them as they are, or I can even simplify it now if I want to, but I'll just simplify it in the next step, so I'm doing all of it at the same time. Okay, so now in this step over here, I'm now going to go and simplify this. So I've got 3 over 4 minus 2 over 4. Remember, we subtract the numerators and the denominator stays the same. So it's 3 minus 2 is 1 over 4 stays the same, so it's 4. So it's 1 over 4 a squared. Then the same thing happens over here. I've got negative 8 over 5 plus 13 over 5. So I'm going to work out the numerators. So it's negative 8 plus 13. That gives me 5. So it's plus 5 over 5a. But now I can't leave this as it is. The 1 over 4 is fine because that's already simplified. So it's 1 over 4a squared, but 5 over 5 I can simplify. 5 goes in there once, 5 goes in there once. I end up with 1 over 1, or just 1a, which I can just write as a. So that's what you should have got for question C, a quarter a squared plus a. And that is how we work with algebraic expressions. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.